In this video, we are going to reveal some of the biggest myths about the brain. When it comes to our brains, sometimes it's hard to distinguish what is fact and what is a myth. Usually, most people think that we are using different sides of our brain to perform specific tasks. Also, many of us are thinking that the brain can change drastically as we age. These two and many more similar questions we are going to discuss during this video. Please make yourself comfortable. Let's begin. Can our brain adapt to injury? Well, this is a fact since the brain can adapt to injuries such as head trauma or stroke. This process is called brain plasticity or neuroplasticity, and this is the reason why so many brain injury survivors can make astounding recoveries. Neuroplasticity refers to both the creation of new neural networks and adaptation to exciting ones. If you begin a new hobby, for instance, your brain will likely start creating new neural connections to help you improve, and if you stop practicing that hobby, those neural connections may fade as you stop experiencing it frequently. When you are experiencing brain trauma, many of the neural connections you once had become damaged or destroyed. This explains why you can even lose the ability to speak after the brain injury. While the brain does not generate new neurons after the injury, it can compensate for that loss by changing the way information flows throughout the brain. That's where neuroplasticity steps in. Through neuroplasticity, the brain can form new neural pathways, and therefore repair some of the damage it sustained. It can even transfer functions that were once held in damaged parts of the brain to new healthy areas. The brain can rewire itself so that healthy neurons can form new networks. Synapses are the connection between neurons, and they are in a constant state of revision and modification. One of the most important discoveries in the field is that brain activity can stimulate this process. This is called activity-dependent neuroplasticity. Brain exercises and rehabilitation are crucial in recovery from brain injury. This allows the brain to relearn functions that were lost due to trauma. Your IQ determines your brain size. The size of the brain is not linked to intelligence or learning new material. We still don't know all the biological processes of intelligence. However, intelligent people probably have better connections between their synapses. In addition, their neurons have stronger networks in certain brain regions that allow the brain cells to communicate with each other more efficiently. Some studies suggest that more intelligent people may have thicker cortices, particularly in some parts of the brain. The cortex is the computational part on the outer surface of the brain, where most of the brain cells are. Other studies have reported that in females, the cerebral cortex tends to be thicker than in males. This might account for the fact that, despite having relatively smaller brains on average, there is no effective difference in cognitive performance between males and females. To be completely clear to you, let's mention again, this is a myth. People use different sides of the brain. This is a common misperception. There is no scientific basis for the notion that individuals use one hemisphere of the brain more than another for certain cognitive functions. This theory first came in place in the 1960s, from the Nobel Prize winner and psychobiologist Roger Sperry. As per his theory, left brain is more analytical, verbal, and orderly than the right brain hemisphere. Sometimes left brain hemisphere is called the digital brain. It's better at the things like writing, reading, and computations. According to Sperry's dated research, the left brain is also connected to logic, sequencing, linear thinking, math, facts, and thinking in words. The right hemisphere is more visual and intuitive, sometimes referred to as the analog brain. It has a more creative and less organized way of thinking. Sperry's dated research suggests the right brain is also connected to imagination, holistic thinking, intuition, arts, rhythm, nonverbal cues, feelings, visualization, daydreaming. A team of neuroscientists set out to test this premise. After almost 2-year analysis, they found no proof that this theory is correct. The magnetic resonance imaging of 1,000 people revealed that the human brain doesn't favor one side over the other. The networks on the one side aren't generally stronger than the networks on the other. The two hemispheres are tied together by bundles of nerve fibers, creating an information highway. Although the two sides function differently, they work together and complement each other. Once again, you don't use only one side of the brain at a time. Is the brain fully mature by the age of 25? Well, to be honest, we must say that this is a fact. Even if a teen is fully physically developed, that doesn't mean that they are fully matured, brain-wise. One of the biggest differences researchers have found between adults and adolescents is in the prefrontal cortex. This part of the brain is still developing in teens and doesn't complete its growth until the mid-20s. The prefrontal cortex performs reasoning, planning, judgment, and impulse control, necessities for being an adult. Another essential part of a developing brain is the network of neurons. This large network in the brain allows cells to communicate with one another, carrying signals back and forth between the brain and the rest of the body. Researchers point to the fact that a healthy mind means the ability for that network of neurons to change. So once again, it is true that our brain isn't fully developed till the age of 25. Does alcohol kill brain cells? The truth is, moderate alcohol doesn't kill our brain cells. However, constant drinking can damage the ends of neurons, called dendrites. This damage can affect the ability of neurons to convey messages to each other. In addition, people with alcohol addiction can develop a neurological disorder called Wernicke-Korsakoff syndrome, resulting in vision changes, loss of muscle control, and impaired memory. Available data suggests that about 25% of those who develop Korsakoff syndrome eventually recover, about half improve but don't recover, and about 25% remain unchanged. Some research suggests that those who recover from an episode may have a normal life expectancy if they abstain from alcohol. So, don't be scared if you want to have a drink or a couple of them. Enjoy your life and be reasonable in everything you do. Do brain games improve our memory and reasoning skills? As per the BBC study in which they commissioned to investigate this theory by asking more than 8,600 people aged 18 to 60 to play online brain games, designed to improve memory and reasoning. The participants played the games for 10 minutes a day, 3 times a week. The study showed that after 6 weeks, the test subjects didn't demonstrate improved cognitive function in tasks for which they did not specifically train in the games. Our brain works better under pressure. The truth is, though the pressure of a deadline can motivate you to work harder, it doesn't result in better brain performance. Stress is more likely to impair brain function. As far as we can tell, no evidence supports the hypothesis that today's pressure, or exposure to unpleasantness, helps our brain to cope with difficulties that he will face tomorrow. We can say that this depends more on the individual level rather than on all of us. Babies exposed to classical music end up smarter? Although it's tempting to believe, there is no evidence to support the idea that playing classical music to a baby can make the baby smarter. This idea was taking place in the early 90s, and it's still popular today. The story behind this myth is founded in a study published in Nature magazine in 1993. In this study, conducted by researchers Francis Rauscher, Gordon Shaw, and Catherine Kay of the Center for Neurobiology of Learning and Memory in the University of California, they studied around 40 college students from the university and asked them to perform spatial temporal tasks after listening to 10 minutes each of Mozart's sonata, a relaxation tape, and silence. After listening, the group was given a test to measure spatial IQ, and after listening to Mozart, they scored an average of 8 to 9 IQ points higher than after 10 minutes of silence. The most important thing that people try to avoid when they are mentioning this study is that all the cognitive gains lasted only for 10 to 15 minutes. An even more important misconception of this study is that the study itself was not conducted on babies. But the word was spread around the world, and many pregnant women were unnecessarily listened and played classical music to their not yet born babies. Even since several studies have completely debunked the prevailing theory, like the one from the University in Vienna, in which scientists found no evidence that listening to Mozart can enhance cognitive abilities in any way, but, as we said before, people still holds up to the previous theory. You may ask yourself, but why? The simple answer is because we still love instant or simple solutions. Can't get kids to eat? Give them this. Can't put them to sleep? Do this instead. Want them to grow smarter? Open Spotify and find a classical music playlist. We hope that you enjoyed this video. See you in the next one.